For problem 7, we have the quantity x cubed raised to the 8th power. To simplify this, all we need to do is multiply our exponents. So x, and then we have 3 times 8, and this simplified is x, not 8, x to the 24th power. For problem 8, we will be adding our exponents because we are multiplying them. So when they have the same base, you add their exponents. So n 5 plus 2, and then r is up to the 3 plus 4 power. So simplified, that is n to the 7th power, r to the 7th power. For problem number 9, to simplify this, we will subtract our exponents because we are dividing. So we will subtract 2 from 6. So that leaves us with m to the 4th power. And then when we have n to the 3rd power and we subtract 6 from that, that leaves us with n to the negative 3rd power. But when we have a negative exponent, we have to write it as the reciprocal, so m times 1 over n to the 3rd, which is really, or m to the 4th times 1 over n to the 3rd, which is really the same as m to the 4th over n to the 3rd. Another way to look at this is if we expand it, we have m times m times m times m times m times n times n times n over m times m, and then n times itself 6 times. Then what we can do is cancel, and that will leave us with 4 m's on top, which is m to the 4th, and 3 n's on the bottom, n to the 3rd. So there's 2 ways to look at that. For problem 10, we'll start with the exponent outside of the parentheses on each problem. So negative 2 to the 4th power is a positive 16, and then we will multiply our exponents, so it'll be h to the 4th power, k to the 4th power. And then we'll have 4 to the 2nd power, which is 16, and we're multiplying our exponents, so h to the 6th power, k to the 10th power. Now we will multiply them by each other. So we'll have 16 times 16, and then we'll have h to the 4th power plus 6, because we're adding our exponents here. And then we'll have k to the 4th power plus 10. And that will be simplified as 256, h to the 10th power, k to the 14th power. For problem 11, we're again just simplifying here. So we need to just add our exponents because they have the same base. And we can't forget that there's that imaginary 1 there. So we've got 4 is our base, and our exponent is 1 plus 4 plus 4, which is 9. So 4 to the 9th power. For problem 12, we are simplifying again. So we'll have 3 times 4, and then we add our exponents when we are multiplying. So it's m to the 1 plus 1 power, and then times n. So this simplified as 12 m squared n. And then again on 13, that's like problem number 9 that we did. We just keep our base the same, and we subtract our exponents. So we've got 3 to the negative 3rd power, but we need to write that as its reciprocal, and that's 1 over 3 to the 3rd power, and we keep the exponent positive. For problem number 14, I'm going to break this up into the 3 different parts. So I've got 36 over 9, b to the 4th minus a negative 1, because we subtract our exponents when dividing. And then I've got c, and then subtract my exponents again. So 2 minus 5. So I'm left with 4b to the 5th, c to the negative 3rd, and then our c to the negative 3rd power will move to the bottom. So we'll be left with 4b to the 5th power over c to the 3rd power.